There we go. And the recordings from yesterday, working on getting those uploaded. There's just some funny business with my machine, so I need to go to another computer to upload them. But day one's part 2 video should be available at least. But after after we get everything uploaded, it should be at that link that I sent yesterday. Just all of the files along with some guides, some written guides to go over. All right. So first and foremost, I was wondering whether or not you would like to cover the IMU processing side of things. It would be within software called POSPAC. If you have that set up, that's perfect. If not, we can move on to just the Riprocess portion. Just was curious to see what your thoughts might be.
¿Ustedes qué cosas han visto hasta ayer? Porque él dijo como algo de subir unas guías y... Please give us a second.
Yeah, no worries.
So basically, yesterday, will you provide us some guides? Or...
Yeah. So at the link, there should be a document. I can actually share it on my screen.
Yeah, sure.
Thank you. It's a very, very long document, which is, it's okay. Just to inundate, it's a lot of information at once, so it can be definitely trimmed.
Okay.
Yeah, it's 13 pages. So
that's a lot.
Yeah. So it goes over basically all steps for data processing, especially with the 780. It's all written, so it's a little wordy. There's not a lot of pictures in here. This is actually written before my time, but it's very good information.
Okay. Yes, that's good.
But it has basically every single aspect of processing written down. Okay. I'd say you could maybe trim quite a bit of this, but it also goes over the scan data adjustment process in the case of Boresight, which we'll cover a little bit today. But yeah, it's quite a bit of information. I hope to provide you a more easy to digest.
See your screen. Sorry.
Oh, sorry. Yes. Let me see if it. Oh, I didn't click yes to click share. That explains it. It's it's this document here. Oh, no problem. Yeah, it's a rather large document. Yeah, so it goes over trajectory, post-processing, and then over the GeoSys manager, which we'll cover today, generalized data processing and Riprocess, which is usually what we'll be encountering anyway. And then even Boresighting, which would be under the scan data adjustment process, which is one of these here. So if that's necessary, this won't always need to be done, but it's good to know how to do a Boresight for your sensor.
Okay. So let's wait some minute while Eduardo comes here and we'll continue.
Yeah. Absolutely. Yeah, of course. I do have these videos here for the acquisition side. I know we're talking processing today, but if you have some time, even in data processing, it's nice to see how the acquisition is taken. So you get some context. Usually the acquisition checklist is the best one to watch.
Okay.
So if you see an issue in post-processing, then you can maybe surmise what may have happened in acquisition. So it's a good thing to check.
Did you provide those videos to Eduardo or Andres?
I sent it straight to Andres. So hopefully he'll forward the links. If not, if you give me some addresses, some emails, I can forward to everyone. Yeah. Yeah, it should have all of these videos along with some specific manuals for the 780 and the demo data as well available.
Okay. So here we are.
Perfect.
So
I will forward those
the
now.
first one is incorrect, but let me.
Oh, sure.
There it is. Okay. Yes. Those are
Excellent.
the
Thank
emails.
you.
Yes, that will be helpful because Andres didn't share here. So
Yeah,
thank you.
absolutely. Also, we will have um, a license that I'll send via
Mhm.
email. This would allow us to process the demo data. It should be good for 2 weeks from now. So even after the training, if you want to go back through the demo data, then you can once more practice.
Okay.
That link should be coming through shortly.
Básicamente vamos a ver dos procesamientos hoy. Lo del Borsight y el primero es la adquisición de los datos. Eh, que si tenemos parámetros, pues justamente para nuestro sensor, fue lo que preguntó primeramente. En cuanto a lo del Borsight. Si no, pues que podemos trabajar con los datos, pues con los datos que ya tienen. So Eduardo just wrote me about if we could start. So
Okay.
it's okay
Sure.
to start right now. So thank you.
Of course. Yeah, we'll do. All right. So firstly, what I usually like to do prior to even processing is to talk a bit about the.
Are you sharing your screen? Okay, yeah.
Oh,
Thank you.
yeah. No worries. So what I usually like to do before processing is to talk about the differing folders and the primary ones we want to keep in mind. Yesterday we did talk about how data is offloaded from the system. But just to reiterate, we use a software called ext4copy. I, of course, don't have a drive loaded, but the idea is you take the raw data drives, insert them into your computer or into the USB adapter, and you can use this software to copy all of the data, primarily the O3 Regal raw data, the raw data, into your project folder. And every RiAcquire project, every acquisition project will create a folder with a structure like this, very similar. So this software, ext4copy, will be used to copy this data.
Which software is?
So for ext4, this is the Linux file system that's being used by the scanner. And to be able to transition this into Windows, we need to use an adapting software because it's not native to transfer from Linux to Windows necessarily. So
please give me a second. I will explain the.
Perfect.
Bueno, básicamente ya estamos con la primera etapa, ¿no? Que es una vez se capturan los datos y llega la información a la oficina, siempre van a ver o se van a crear esos archivos que están ahí en pantalla. Entonces, lo primero es que va a haber como un software que es este el que tiene ahí, que se llama Copy, bueno, en la guía ahorita lo mostraba, exacto, Xcopy.
Export copy.
Ujú. Y eso de por sí siempre se van a crear esos últimos archivos que se encuentran allá abajo, que es BQ780 y bueno, pues todos los que están de ahí hacia arriba. Para todos los proyectos se va a crear eso.
Perfect.
Yeah.
All right. So once you've copied all of your data into the same folder, there are a couple folders to keep in mind. So firstly, we have the raw data folders. At least in your case, we'll have the raw scan data in raw INS data or the raw IMU data.
Sí.
So just to touch on the IMU data, generally, this particular project doesn't have such data, but it will all be stored in this subfolder O2 fold.
Ok, sí. Van a haber dos folders importantes cuando se copia la información. El primero es este que dice ins GPS raw, pues es la información GPS cruda y toda la información pues va a estar en la carpeta que se llama full. It's okay.
Yeah. Okay, perfect. Yeah, so this particular project does not have this data, but this data actually is not needed to be copied usually. It will be generated automatically in the course of acquiring the data in the first place. So the only really thing to do here is to check that it is available prior to processing.
Ok. Lo único, la información se copia automáticamente en esa carpeta. O sea, viene desde la adquisición de datos en el sensor, él crea esas carpetas y las pone ahí en la carpeta full. Lo que uno tiene que hacer como primer paso es chequear que ahí haya, o pues que estén los datos. Pues que en este caso, en este ejemplo, no hay información, pero pues que tradicionalmente o normalmente sí van a haber los datos. Ok.
Perfect. There is another folder here called O3 base. Here for your benefits, this is where I recommend copying your base station data if you are using a base station to help process your trajectory. So presently, of course, there's nothing here. Next, we have the O3 Regal Raw folder. So this has a few useful things. So first and foremost, we have the O2 RXP folder. This is where the actual scan data from the collection will be.
Ahí es donde va a estar la información que se colecta de los datos en esa carpeta RXP. Ahí, tan pronto se capturan los datos, ahí es donde va a estar la información que fue adquirida, pues cruda.
Sí.
The LiDAR files, yeah.
Exactly. So you have RXP, Regal extended packets. This is the main LiDAR data.
Okay.
One thing I recommend too is it's common, unfortunately, for copies to sometimes not be complete. So it's good to always check for data integrity. You can do this with scripting or by using some software such as 7-zip or NanoZip. You can run a CRC32 operation.
Bueno, siempre es importante verificar que la información esté bien. Y eso lo pueden hacer a través de could you please do it again?
Sure.
A través de NaNzip and CRC32. Ahí se verifica la integridad de o sea, de que sí hayan datos. Entonces, ahí precisamente vamos a evidenciar, pues, qué información hay. O sea, que sí hay información dentro de esos datos.
And then once you've run the CRC32 operation, you can compare that to the contents of a file. So there's always a CRC file accompanying a RXP. So we can open this up and compare whether it copied over correctly, which, let's see. So actually this needs to be recopied because the values do not match. So I will need to recopy this particular file. We can check for the other ones as well. But see, it's a good thing to always check because this would have even caught me.
Yeah, of course. ¿Sí entendieron ahí más o menos? La idea es comparar esos dos archivos. El primero, que es el RXP, con esa herramienta Nancy, en CIR32 le va a dar un numerito. Ese numerito tiene que ser exactamente igual a lo que está en el archivo que con extensión CRC. Ajá. Y pues ahí, o sea, esa misma información tiene que estar en ambos archivos. Con eso se dan cuenta de que la integridad de los datos pues es correcta.
So I'll likely recopy this maybe during a lunch break or so, just to make sure, and then I'll upload the new copy as well. But case in point.
Okay.
Elsewhere in the O3 Regal raw folder, we do have some other data that's just good to be cognizant of. It wouldn't presently be with this system, but I can maybe show you another example. It can also be seen directly in the project, which we'll get into. But there is some options to check the laser configuration used for the flight. So you can see based on what was done in acquisition, if it was flown accordingly. So this can be good if you are unsure if the correct configuration was used. In 05 sys 01 laser config. Okay.
Two? Okay, yeah.
Perfect. Next, we have our data processing folders. So,
hey, Travis, please.
Yeah.
1 sec. So for every project, we will copy all these files, or it automatically will?
Oh, good question. Yes. So these files, the only files you must copy will be the RXP files. The rest should be automatic.
Ok, sí, eso automáticamente se genera.
Ok.
Eso es lo que viene automáticamente generado.
De RIA
So
file.
these are
Sí,
the
exacto.
De RIA file.
Sí, o sea, una vez se capturan los datos, se crean esos, o sea, se tiene sí o sí esas carpetas.
Y toca traernos todos los directorios para acá, para todo lo que se graba allá.
Ajá.
¿Qué son esos? Okay.
Exacto. Yeah.
perfect.
And the other ones, well, so I think, or I understood that maybe Regal route does the O3 and the O2 Regal GPS route. There are those are files which automatically will be provided by the sensor. Yeah.
Yes. So the O2 folder, everything within will be automatic. Excepting if you have a base station, you must of course copy this.
Okay.
And
If not, if not, it will be a problem if we don't have a base.
No, there are methods out there to correct for without base station data. So mainly Aplonix offers PPRTX as a solution, which it's like it's a subscription service that you can use to help correct for trajectories. Otherwise, there's PPP and things like this.
Yeah, sure. We use PPP.
Yeah, exactly. Yeah. So you don't always need a base station. Yeah.
Yeah, of course. So, entonces, esas dos carpetas, las que ya les había dicho a ustedes, la de RAW y la 02 y la 03, que es 02 INS GPS RAW, y la de Real RAW, pues son las que automáticamente salen de allá del sensor.
Okay.
Pero las otras entiendo que son las que se tienen que copiar. So the other ones we have to copy there. So for example, the O4 and the O1, we have to copy those folders, or maybe
Oh, so the main things that you would have to copy would be the O3 Regal Raw, O2 RXP. So just this part will need to be copied.
okay.
Yeah.
And the other ones will be
So
provided automatically when we open the real processing. I think it is the name of the reprocess.
Oh,
It
yeah.
will be
So many of these,
automatically generated.
yeah, many of these folders will already be available. So they will be populated essentially with the data from the raw collection, excepting the O3 Regal Raw. So all of these will be created for you already. So no worries.
Okay.
Yeah.
Yeah.
I did want to highlight the 05 and 06 folders. So these are the post-process data folders. So 05 will be where the post-process trajectory data will live. So within this, for this project, the trajectory data has already been processed for us. So it's already been converted, and I'll show you the conversion process into O1 POS, where we have our trajectory data. So the formatting is POFX for the actual trajectory post-processed. It has the orientation and so on. And the POQX is the quality. So things like PDOP, accuracy, these are stored in this file.
Básicamente, cuando se procesa la información, se generan esos dos archivos que están ahí.
Okay.
En ese último habla de la calidad de la información. And the first one, it's about...
Yeah, it's all the position data. So it has the position as well as the orientation.
Las orientaciones y demás. Okay. Información. La de abajo es la de calidad, de quality. La Q es de calidad. Okay.
Yeah, and this is following our trajectory processing done in POSPAC. Of course, I can briefly touch on this too if you guys are unfamiliar with POSPAC at all. This is helpful.
Yeah, we're familiar with POSPAC.
Okay, perfect. I'll just show then the process of converting an SBET.out into a POFX.
Okay.
Perfect. And then O2 project, this is just something for your benefit. You can place the POSPAC trajectory project directly in here. So when you're doing your post-processing, everything is local in a similar place.
La información que copia el GPS, los default, toca procesarlos en POSPAC. O si se procesa ya la información GPS acá en Riprocess.
We process the POSPAC information in Riprocess or in the default files, or in which software we could process that information?
That would all be within POSPAC MMS or POSPAC Complete. So it would be this software. It's offered by Aplonix, which is one of our partners. So this is what will be used for computing the trajectory. This is slightly newer. POSPAC, you may be familiar with POSPAC MMS.
Yeah, sure. So en sí o sí, pues se utilizará POSPAC. So in the reprocess, we can't process the GPS files, the default files, isn't it? So we have to use Aplonix POSPAC.
Yes, unfortunately, that is the case. Yeah.
Sí, básicamente es eso. O sea que sí o sí, pues en POSPAC es donde se procesa esa información.
Yeah, so this may be different than the version that you have. This is relatively new. It came out in January.
We could do an example after this brief, which we could do here every step. since the acquisition data and those things, just because probably here we have to know how to use every software, so it will be helpful.
Yeah, most definitely. I can definitely do that. Yeah, so after the brief, I'll process an example trajectory, and then we can import that in Riprocess just to show this step. Yes.
Okay. Yes. Thank you.
Of course. Yeah. Next is the 06 Regal proc folder. So this is just having the post-processed Regal data. So primarily the RDBs, the raw data will, well, not the raw, the post-processed data will come in here. So you'll have the records and their subsequent files, which we'll touch on a bit more, but this is just to know where all of the data is post-processing to prior to export, because we have not yet exported in this project yet.
Okay. Básicamente ahí es la información ya postprocesada, pero la anterior era del GPS, ahora esta es de los datos live.
¿Pero son los que copia reacquire o son los que se traen de los discos del grabador?
No, los discos la información de los discos del grabador va ahí en la carpeta 03, Regal Route.
Ok.
Y una vez procesada, se crea esa carpeta Regal Process.
Okay. ¿Y por dónde se pasan los archivos RXP?
Uy, no sé. The raw RXP files. ¿Cuál es la pregunta?
¿Por dónde se procesan?
In software? Sí. In which software will be processed? In Riprocess or?
Yes, that's right. Yeah, okay. So the 03 Regal Raw from ext4 will be used in Riprocess, yes.
Okay. Sí.
Yeah.
Igual, él ahorita nos va a dar un ejemplo desde cero, desde que se tienen los datos y vamos a procesar toda la información. Ahorita es como entender como cada carpeta, como cada cosita. Okay.
Perfect. Finally, this 07 protocol folder, this is where you might store a report following processing if you've performed adjustment. So maybe you do a strip adjustment or you do a bore site. This is where that report will be following doing such a thing. So it's good to keep that in mind.
Ok, en la carpeta de protocolo pues se guarda como todos los ajustes que uno quiera poner ahí, los reportes, lo del board site, como todas esas vueltas se ponen ahí en la carpeta de protocolo. Okay.
Yeah. And finally, I'd say the most important folder, in my opinion, other than the raw data folder, is 08 received. So this has a backup of your project data, which is all of these files down here. So in case you have an issue during processing and you can no longer open your project, you can come in here and then retrieve these files, copy them out to where I've highlighted, and then you can recover your data.
Okay, but in this folder, I have to do it manually or it will be created automatically?
Automatically, yes. So as soon as the reacquire project is complete, this folder will be generated as a backup. So it's not necessarily a backup of all that you've done in post-processing just yet, but it is a backup of the project fresh from reacquire, so immediately after acquisition.
Okay, that's cool.
The other, you can, sorry, didn't mean to jump into the next bit just yet.
Okay, thank you. Pues es que la carpeta más importante para ellos es esa carpeta que se llama Receive. En esa carpeta se crea automáticamente, o Riprocess la crea automáticamente y es una carpeta que guarda el backup de la información. O sea, como de todo el procesamiento es un backup. En caso de que algo se corrompa o como que se daña o cualquier cosita, esa carpeta guarda como el backup de los datos. Entre todo, pues ahí también va a ir un archivo que se llama .back, que es ese que está ahí. Y ya. ¿Sí? Okay.
Perfect. And the other backup that you have as well for just the progress of your project is this .back file. So if for whatever reason my RPP, which is my project file, is lost.
Archivo del proyecto. Y si ese se pierde, vamos a tener el archivo que es .back.
Ok.
Ese es el back del archivo principal del proyecto. O sea, es como una segunda opción.
Como info.
Exacto. Y es like info, isn't it?
Yes, exactly. Yeah. So you'll notice that these files are identical in size because they are indeed the same. So
Si ven que tienen el mismo peso, entonces es lo mismo. Entonces el punto back, pues es el backup. Y el RXP es como el principal, pero entre todos, si se necesita recuperar, vamos a tener esos dos que tienen el mismo archivo y entendería que lo único que va a hacer es renombrar el punto back. Ok.
Perfect. Okay. I think at this point, it's good to maybe transition into doing some post-processing, if that's all right. We can get started on some trajectory processing just so you are familiar.
Yeah. Ese es un video, weón, el 2, que el man dijo, pilla, ese es un video que el man dijo que es muy importante ver, que básicamente comprende todo, o sea, como toda la parte también de procesamiento,
Ok.
de adquisición de esos datos.
Ok. Bien.
O sea, como para que es una cosa aparte.
Ok, ok.
All right, and let me just get up a project that is pertinent to what we are doing. Okay, so I will use an example project that is of actually a slightly worse sensor than yours. It is simply a VQ580, not a VQ780, but the idea remains the same. So I will remove my present project that I have in here.
Yeah.
And now we can start. So firstly, you will need to create a default project. There are some templates that you can create, but I usually do not bother. I just simply create a default project. And let me also make this into a very familiar screen, the plan view.
Okay.
Okay. So now I will need to import my data. So if you go to the project tab, you can import data for this project. So I will go into O2 INS GPS raw.
¿Sí entienden de dónde nace esa carpeta? Eso se supone que sale, o sea, de lo que yo entendí es que sale directamente del disco de grabado.
Ese es del disco
De capturar.
pero de la navegación, ¿no?
Sí.
The default files.
Those are the default files.
Yes. So from require, these folders and files will be imported.
Okay.
Llegará en la PC card.
Sí.
Okay.
All right. So I've selected my directory in this import folder page. Let me remove this filter. And now we have many different files. So you will likely see something similar. There is a .raw, or perhaps in your case, a TO4 extension. And then there's these numbered files that you can use for import. So the .raw or TO4, as was specified on your device, is the full trajectory all placed into one. So you can use this file as your initial import. But if there are any sort of network interruptions in flight, a good usage of these files can be used, these numbered files, and they can all be imported identically. So like so. So it depends on which you want to use. So you can either use a singular file or many files for the import.
Pero, entiendo que va a depender de nosotros cuál de los dos querramos utilizar, pero no entiendo es cuál. Which is the difference between the first one and the other ones?
So for this one, it's the continuous file that was collected over network on the laptop. And these files are downloaded every 15 minutes. So,
Okay.
Yeah.
Cada 15 minutos se crea esos archivos individuales automáticamente.
Con el fondo.
in where those files are created while I acquire the data or while we fly or
Yeah. So these are all created while you fly. So this .raw in this case file will be a larger file. So let me actually better show. I think this was a incorrect start, so I actually might even remove this one to remove confusion. But you'll see this file is much larger because it contains the full trajectory.
ese contiene
and
toda
this
la
is
trayectoria del avión.
Pero son archivos de reacquire o son archivos que se crean en la física.
Those are files that are generated by reacquire or maybe by the physics card in the flight.
Very good question. That's actually a good distinction. So this is created by reacquire, this one, and this is written to the PC card. All of these files are on the PC card.
Están mezclados.
So they are mixed. So
Yes.
when we open the reacquire, so probably it will automatically generate the first one and the other ones are during the flight mission.
Yes.
Yeah.
Yes. So they'll be downloaded every 15 minutes.
Y Postpack procesa también la información que viene de reacquire, la información GPS vino.
Postpack also process the reacquire information.
Yes. So they contain the same information. It's just the extension is different, but it's all the same info.
So please give us like
Yeah.
no worries. Wants to check something.
Absolutely.
Que de pronto no le queda.
Lo que pasa es que los que nosotros procesamos aquí normalmente son los datos, los de navegación, los default. Sí, pues
Y esos default cada cuánto se generan.
Eso se generan cada 12 megas, pero en tiempo no sabría decir. Y el reacquire genera también su propia información GPS, que son como especie de unos archivos RINEX con extensión T04. Aquí yo veo que son otra extensión. Así. Entonces no sé si eso se parametriza ya en reacquire, cuál del archivo.
So previously we checked that Riprocess give us some files with extension T04.
Yes.
But here we check that there are different extensions, CRC, probably, and RAW. So those are different or different files or extension or where we could parameterize those things.
Yeah, that's a good point. So these files here are they're using NEMA messages, and then TO4 are using GSOF messages. So it's two different formats supported by Aplonix. They should work identically, but that's the distinction, is the content of the messages. Aplonix will identify automatically which type it is to process.
Ok, sí, son dos archivos diferentes, o sea, porque vienen de dos lados diferentes, pero básicamente el postback debería procesar y asimilar exactamente lo mismo.
Démosle qué diferencia hay en solo procesar los archivos de la física, los default, y incluyéndolos los archivos que se generan en reacquire. ¿Hay alguna diferencia? ¿Hay mejor precisión?
There are some difference between files processed with reacquire versus the those one which are directly by the physics card.
Yeah, so there can be differences, especially if there's any network troubles during the flight, because the reacquire generated trajectory data is what the data stream is available over the network in real time, which should have the same density.
Sorry, Trace. Could you repeat the last phrases, please?
Yeah. So the reacquire generated trajectory data is Ethernet stream data, so it's over the network. If there are any interruptions, then it can be incomplete as compared to the files downloaded directly from the PC card.
No, we didn't catch it. Sorry.
Oh, can you hear me okay? Maybe I can try a different microphone device. One sec.
No, yes, I hear you good, but technically I can't relate it with Spanish. So
Oh, I see. I see. So for this is like a continuous stream of the data, and this is
Okay.
downloaded from the PC card. So the difference is just how it's collected.
okay, but there are some difference between quality or precision or those kind of
Oh.
things, or
No,
those
no.
are just the same.
But it should be the same, yes.
Okay, so but los de la physical son los individuales, ¿sí o qué? ¿Qué hace Reacquire? Crea un único archivo de toda la trayectoria, o sea, metes todo en un solo lado, pero no hay ninguna diferencia en precisión, calidad de los datos, nada, el marica como que solamente lo une, ¿sí? Pero los archivos individuales de la physical, es lo que su merced me dice, son exactamente lo mismo que el archivo que genera el React es ese. ¿Cuál es la diferencia? Pues que el otro es un archivo completo, continuo de toda la trayectoria. El otro son archivos individuales. ¿Sí?
Sí, sí, sí. Entonces, es la misma información, usted igual la mete en postpack y el man le procesa todo.
Sí, y ya va a depender de uno cuál utilizar, si los individuales o el completo.
Igual lo mete y no en la misma carpeta.
Sí.
Vale.
Ok.
Perfect. All right. But yeah, once I've identified this data, I can ignore the .crc files because these are simply the checks that we looked at earlier to see the data integrity. So
Okay.
I can just select the PhysCard data or the raw data. Just for the sake of demonstration, I will use the PhysCard data.
Él ahí va a utilizar los archivos individuales, como ejemplo los CRC. ¿Se acuerdan que fueron los que verificamos que era la integridad de la información, que era con el programa este? Exactamente, con ANSIP. Entonces, ahí era donde verificamos que sí tuvieran el mismo peso y como la misma información. Pero los principales son los que no dicen CRC. Esos archivos son los propios, pero son los individuales, o sea, es como los default individuales. Exacto. Y el otro, pues, es el completo de la trayectoria.
Let's see.
Ponle por favor el LeverArm.
Let me try
Es una nueva integración que estamos haciendo con el 780 y el IMU va a estar en otra posición con respecto a la antena. Entonces preguntémosle, porfa, debe saber pues, o sea, qué pospa. Entonces, yo quiero aterrizar todo ese tema de los LeverArm que nos ayudara a aterrizar bien de las mediciones.
Could you please help us with some explanation with the lever arms settings?
Yeah, absolutely. Once this finishes import, we can talk about lever arms, absolutely.
Ok. Pues primero voy a meter ahí los archivos y tanto termine, ya nos va a explicar más del tema.
Okay. Firstly, after import, it will ask you what type of antenna will be used or was used. In this case, I know a AV39 antenna was used, but you'll need to update this according to which antenna you have installed on your aircraft. Okay. And next, it will ask me to create a directory for the project, which is always good practice to save the project after import. So I will use this O2 project folder. I'll just call this training. And here we are. We have our trajectory. All right. So with regards to the lever arms, here's an example. Let me see if I can, that should be okay. So these are something that I recommend trying to measure in advance and then maybe setting on the POS controller directly. But this is also, a good opportunity to be able to calculate them in advance.
Hi, Travis. So
Yeah.
sorry, we have connection problem. So could you please repeat the process between the IB39 antenna
yes.
selection? Sorry.
Yeah, yes, no worries. All good. Yeah, so after import, it will ask you what type of antenna you had used.
Yeah.
So you need to just know what antenna was used on the aircraft. I know
Yeah.
on this aircraft was an AB39 antenna, but your aircraft may differ. So it's good to keep that in mind.
Okay. And after the antenna selection, which is the next step?
Oh, yes. So I would recommend saving the project. You just save as and then choose your location. So I chose the 05 INS GPS Proc and O2 project to keep everything together.
Y ahí es donde ustedes guardan. Exactamente. Que es como la buena práctica que el man está diciendo, vean, ustedes van a tener todas estas carpetas, lo ideal es que tengan todas estas y pues eso era lo que nos está explicando en cada una dónde se van a guardar las cositas. Y, okay.
Perfect. All right, and with regards to the lever arms, this can be viewed in the project settings at the top.
Yeah.
So if you go to GNSS inertial processor and then lever arms and mounting angles, you'll see these values. So to clarify what each of these mean, so the reference is what we are referring to as the center of the trajectory. Unless you have some sort of stabilizing mount, the reference is always the IMU anyway. So the reference to IMU lever arm, in our case, especially here, we do not have a stabilizing mount. Everything will be 0.
Si no se tiene algo, ¿cómo es que se llama? Lo de estabilizador.
Estabilizador.
Exacto. Los parámetros, y bueno, y en este caso ellos tampoco tienen giro estabilizador, entonces pues utilizan esa información de ahí. Pero no sé ahí ya cuál sería la pregunta.
Preguntémosle que dónde se ingresa, dónde se ingresa a la medición y qué medición se debe hacer desde la antena hacia la N.
No, marica, me la deja difícil. Which measure we could do between the antenna and the and IMU?
Oh, yes. So this would be the reference to primary GNSS lever arm. This is where this would be calculated.
Sí.
De la antena a la N, ¿no?
From between the antenna and IMU, yes?
Yeah, exact. Yeah. So it's from the IMU to the antenna. And the orientation is using northeast down. So north, east, down. So you are likely to have for instance, a negative meter or so for the Z, since it's going up. And then the X and Y are dependent on where the antenna is placed relative to the IMU.
Okay. Sí.
Yeah.
Pues sí, pues básicamente es ahí donde se ingresa. Sí, ¿es algo más? Bueno, no sé si de pronto.
No, creo que está bien, está bien.
¿Sí?
Sí, sí.
That's okay, Travis.
Ya que cómo está tirada.
And the other spaces, would you please explain everyone?
Yes.
So the reference and the aircraft, which is the meaning of.
Yeah, so for the reference to IMU mounting angles, this is referring to how the IMU is oriented in the aircraft. So direction of flight is always X.
Okay.
Direction of flight is always X. Y is always to the right of the aircraft, and Z is always down. However, if your IMU is installed in such a way that the IMU's direction of flight is not facing forward, then you'll need to account for this in the reference to IMU mounting angles. So in this case, the IMU is installed like so. So the aircraft is facing this way, but the IMU is facing to the right. So about the z-axis, there is a rotation. So a rotation of 90 degrees, and that's accounted for here.
Ok. Sí, pues esa es como la orientación de la IMU respecto al avión. Okay, it's okay.
Perfect, perfect.
And the other ones,
Yeah, and then the aircraft to reference mounting angles, this is if you have installed the system with a angle or a cant. So maybe you have installed the system maybe 13 degrees pointed up or down or so. You can account for this. Maybe if in this case you put the system 13 degrees up, then it'd be like 10 degrees or so. But it's usually not needed. These can remain 0.
could you repeat that, please?
Yeah. So if you in the airplane you install the system with some sort of pitch or roll or yaw, you can account for that here. It's not usual that it's installed in such a way other than pitch. So Y would be the only time you would change this. But if you are installing the system flat into the aircraft, this can be ignored.
A ver, ya esa es la orientación del equipo respecto al avión. Algo así es que le entendí al mal. Entonces, ya, por ejemplo, si hay parámetros de pitch, roll y yaw, exacto. Si hay diferencias angulares que hagan que precisamente se cambien ahí esas orientaciones, pues se acomodan ahí. Si no, pues se puede hacer obviedad a eso. ¿Sí?
Sí. Sí, esa yo una que clara, pero esa explicación se va bien. Vale.
Okay.
Perfect. Yeah, so as I don't have specific lever arms for the GNSS on the system, I'm sure I do somewhere, but as I don't have them, I'll just simply auto-calibrate and set in some basic guesses. But I recommend, of course, measuring the lever arms directly and then entering them like so in here.
Okay. Igualmente también se pueden autocalcular. De acuerdo pues con la información del GNSS.
Okay. Now, once this is complete, then we must go about importing our base station data if we are using it. Well, we don't have any presently, so we can use PPP or something similar. We do have some GNSS modes available here. So based on how you are processing data, you can import your base station data just the same way as done here, and then set that as your primary base station. I can just quickly show maybe the find base station feature goes through the network.
Ahí pues él puede seleccionar una estación base que se encuentre cerca. O el siguiente paso es asimilar la estación base. Entonces, si calculamos con PPRTX, será ahí lo que él mostraba ahorita. O si hay alguna estación base por ahí cerca, él también exacto, se la descarga. O si tenemos información de archivo local, pues se pone en la carpeta de base que se encontraba ya en ese set de carpetas. Se acuerda que había una que se llamaba como base. Ahí es donde iba el S.
Yeah, and this is a bit of a older project, so I don't believe there's any base station data. So we'll just use PPP for our purposes. So, oh, here it is. So we can just select PPP.
PPP.
We can run this and it'll start to download.
¿Han procesado alguna vez con PPP? Toca esperar 2 semanas para las enfermerías finales. Igual la precisión es muy regular, ¿no? Sí. Sin nada comparado con PPRTX.
Y el default también toca organizarlos por boots y eso, ¿sí?
Sí, claro.
O sea, se continúa haciendo igual.
Sí, igualito.
Okay. ¿Son default o se llaman como para decir?
No, esos son porque ellos les tienen ese nombre. reciben eso.
No, nosotros sigue llegando normal.
Sí, y pues eso va a ser un problema porque los reinicios, seguramente vamos a tener varios boots y allá en el avión van a haber informaciones revueltas. Porque claro, hasta ahora estamos empezando a ver cómo es el flujo de trabajo, pero seguramente va a ser mucho más trabajo. Mientras nos adaptamos. Walter Andrés también es consciente, porque ya les hablaba de eso ayer, de eso. Un nuevo flujo de trabajo, pues va a cambiar todo.
There we go.
Yeah.
Now these are imported, and we can run the inertial processor.
No, no, eso está claro. Pregúntele, sí, pregúntele que como si nosotros no supiéramos de la diferencia entre PPP y Fusion PPP, ampliar de diferencias en precisión.
Which differences between PPP and RTX?
Esa es la diferencia de la
In
antena.
precision
Yeah,
will
I'd say
be.
well, I'd say it's the expected accuracy. With PRTX, they have some nicer ephemerides. It is a paid service, so you should expect a higher degree of accuracy from PPRTX than PPP.
Okay. PPRTX es más violento que.
PPP no.
Ajá. Okay.
Yeah.
Y está bien calcular los leverage con esta herramienta.
It's okay to calculate the lerams with this
Tool.
with this tool.
I'd say recently it's gotten very, very good. But it's always best to start with measured lever arms and then auto calibrate based on a good trajectory. So one with a lot of S turns and good satellite coverage, PDOF. But it's actually quite a useful tool, yes. Yeah.
Okay. Sí, que es una buena herramienta, pero lo mejor siempre es como tenerlos calculados. Pero pues de ahí dan, o sea, es algo, dan buenos resultados, pero lo mejor es siempre.
Físicamente.
Exactamente.
Tal cual, vale.
Okay.
Perfect. All right, so I'll accept the results.
Y acá va a estar nuestra primera tarea. Calcular los leverage iniciales que van de la antena a la de. Y eso no va a ser con un vuelo. Van a ser con varios vuelos. Vamos a tener unos iniciales que vamos a medir cuando hagamos el montaje, hoy, mañana. De hecho, me toqué mañana, allá hacer las mediciones. Sí. Y claro, y después va con varios procesamientos, nos está viendo cómo va cambiando y hacia qué sentido va cambiando y hacer un promedio, qué sé yo. Preguntándole eso, que si es bueno tener la medición física y después con varios procesamientos con este software ir digamos, calculando y cómo refinando ese diagrama. ¿No? Muy.
Sí, muy técnica para mí. It's a good practice to measure the leverams physically, and then after a lot of measurements, refine or maybe calculate a really good lever arms data or numbers. It's a good. It's a good. I don't know how to say it in English, but a good practice to do that.
Yeah.
So firstly, measure physically, and then after data acquisition, refine or maybe calculate it, or calculate good part lever arms numbers.
Yeah. So what my customers have done in the past is they measure it directly, and then they run auto calibrate on the next few flights to continually refine it, updating with the old numbers and then logging each flight with the changes. And then eventually it will converge into a very, very accurate value. So it's good to, for the first few flights, to recalculate with auto calibrate.
Ok, sí, después de, es lo mismo, o sea, lo que su me acaba de decir. Se vuelan, se toman datos y bueno, se mide físicamente, después de varios vuelos se va puliendo pues esa información que es como lo mejor que se puede llegar a hacer. Y pues a través de esta herramienta como que parametrizando y se obtienen pues muy buenos valores después de eso.
Sí, preguntémosle que si nos puede ayudar a definir buenas prácticas para definir los cálculos de todos los diagramas, o sea, de los diagramas posteriores que toca hacer entre la IMU y los sensores, o sea, LiDAR y cámara. Sí, simplemente que nos diga, bueno, yo les
¿Se creen que soy Trump? Okay. Could you help us doing or maybe knowing which good practice are going to be helpful to us with these learns or
no, Borsight.
with Borsight are
Para definir para definir las mediciones entre la IMU y el LiDAR y el Borsight.
¿Pero qué quieres saber?
Sí, que digamos nos aterrice muy bien, nos diga, "Ah, estas son las mediciones que usted tiene que hacer entre el punto de referencia del LiDAR y la IMU. Y después,
Yo creo que es mejor también consultarla, ¿verdad? O hacer la pregunta técnica aquí en el traductor,
sí,
porque sí se me hace muy técnica.
bueno, sigamos,
Sí.
miramos eso. Sí, eso lo podemos mirar en Riprocess, cuando estemos procesando la información en Riprocess. Seguro.
Okay, don't worry, Travis. After this good brief, we could do a question, an important question for us.
Sure. Yeah, absolutely. All right. But yeah, beyond this point, this was already done automatically in this new version of POSPAC, but I usually recommend running a QC report so you can get an idea of what the quality of your trajectory looks like following runtime. So diagnostic is usually good. And you can simply generate this report.
Y ahí el que diagnóstico. Y ese lo va a guardar.
And then in the subfolder mission, you will see the report that was created. And then here you can check all of your metrics. So you can see, for instance, what number of satellites was found and whether or not there were any cycle slips, which is basically whether or not you lost view of the satellite, maybe due to a turn. Ideally, you want 4 satellites that are 30 plus degrees at all times throughout to maintain good quality trajectory. So here we see we have 1, 2, 3, 4, 5, 6, 7, 8 pretty much available at all times. So 4 is the minimum that I recommend.
So, lo ideal es que aparezca en verde mayores a 30 grados la mayor cantidad de satélites posible.
Okay.
Mínimo 4. Y pues de ahí en adelante todo puede pasar ganancia, pero pues sí lo ideal es que haya mínimo 4 satélites que tengan ese parámetro de 30 degrees, o sea que aparezcan así en verde,
Sí.
para obtener pues mejor, o sea ya con eso se da uno cuenta qué tan buena es la calidad de los satélites, bueno, o sea qué tantos satélites puedo recepcionar bien en ese momento.
Y la máscara de elevación, ¿no?
Okay.
Perfect. Awesome. Next, the SNR values. So this has to do with noise. So if there is issues for communication to the satellites at any time, you will see issues here. For L1, you usually want the average to be between 38 and 48. We see where we are fairly within the average, right about here maybe. But if it drops below, you maybe need to reevaluate the trajectory.
Okay. Básicamente, en ese punto ya estamos viendo como la precisión de...
Las trayectorias.
Exacto. Entonces, que lo ideal es tener los parámetros ahí en ese rango, entre 49 y 48, ya que, y bueno, y también evidencia como el ruido que se tiene dentro de la información. Entonces, pues ahí el promedio es que está, pues todo va en orden, sí, pero si hay errores o ruidos, exacto, muy, pues muy elevados y que no estén dentro de ese rango, lo mejor pues sí es volver a calcular.
Okay. ¿Y volver a calcular con el mismo método o con otro?
It's good to recalculate with the same method or probably with the same base, or probably we could use the same one and recalculate everything.
Yeah, so if you do run into issues with SNR here, I would consider using, instead of, for instance, the raw data from RagQuire, I would consider using the BizCard data, because this is the trajectory as it's noting the satellites at the time of collection.
Okay. Bueno, no me respondió la pregunta, pero sí es algo importante y es que ¿qué puede ocurrir en el procesamiento que si se usa la herramienta de Riprocess, o sea, la que une el archivo completo? Puede ser que ahí haya bastante ruido porque pues son diferentes momentos en la toma de información. Entonces, ¿qué podría hacerse? No utilizar el archivo completo de la trayectoria, sino los que están individuales, para con eso el ajuste se haga de mejor forma.
Ya lo de la física.
Los de la física, exactamente.
Los otros archivos simplemente nos sirven en caso tal que
Ujú.
nosotros se necesiten. Vale.
Okay.
Awesome. All right. Next, we'll keep going. Just want to show you some other graphs that I like to look at for quality control. So for the acceleration, this should not exceed, it should always be less than 1G. So here we're doing fairly okay. But if you have too high of accelerations, it could be an issue. Yeah.
Bueno, no sé si grado, pero pues sí, menor a 1.
Okay. Okay.
So we're looking good here.
Bueno,
Yeah.
está bien.
Particular rates. Likewise here, same idea, less than 1G. Okay. Where's our forward reverse? So a quick thing with regards to these values, so the reference frame performance errors, usually you want these to be relatively stable throughout. Otherwise, it may indicate an issue with the IMU. So you don't want to see sudden.
Okay. Okay.
You don't want to see that on any of these.
Okay.
So
If so, what we could do, just in case if we saw this.
I would compare it across several flights, and then if the issue remains, I would reach out to Aplonix, because usually this indicates an issue with the IMU directly. Yeah, so of course the magnitude matters as well. So here is okay because the magnitude is very small. But if it's a very high magnitude, yeah.
No importa, pero la cosa sí es cuando sea muy pronunciada.
Yeah. But usually you'll only check these if you already have an issue processing the trajectory, so there's an error. I would check these. So sometimes this, just for, there's actually a document that I think. So I can share for you, where is IMU 31? So these are the ranges that you would expect for your IMU, just to keep in mind.
This PDF file, did you provide us, or please could
well-
you share with us?
I don't know if I could share the whole thing because it's an internal note from Aplonix, but this is at least very good information for checking if there's an issue with the IMU. So you can use that in tandem with these graphs to see if you are in excess and there might be a need for service for your IMU.
Okay.
I'd have to, I might check with Aplonix directly and see if it's okay to share. So I'll let you know maybe sometime next week.
Yeah, thank you. I will really
Yeah.
appreciate that.
Absolutely. Okay, finally,
Básicamente,
we
los
are,
errores, disculpa, son los errores máximos que se podrían llegar a tener. O sea, pues lo recomendable es que se tengan. Y pues con eso ustedes comparan acá el error y las variaciones, y pues con eso lo comparan con el PDF, y con eso pues estar seguros de que está bien, ¿sí? O sea, ahí es cuando ya son los rangos que el man habló, pero pues ya en esa tablita. Lo que el man va a hacer es consultar si nos puede pasar esa información.
Ok. Ese es el documento que tiene.
Sí, donde están los errores permitidos y toda esta vaina.
No tengo una situación que también otra vez.
Sí. No, pues yo no estuve.
right. So finally, we
Okay.
have the position error. The smooth performance metrics is the actual position error of the final product of your trajectory. So with this, you can see this is around 8 centimeter accuracy for the z-axis. And then for the x and y, it's around 3 centimeter, maybe even better.
Okay. ¿Quieren preguntar ahí?
So you can use this as a guide. Sí.
O sea, que así tal cual como está, ¿cómo lo ve el resultado?
Basically, in this case, how good is the result? It's good. It is good, or probably.
I'd say for usage of PPP, this is an okay result. Because usually I'd expect PPP to be, a little less accurate than PPRTX. PPRTX you might see with a high grade IMU around 3 to 4 centimeter down position error, so Z. But with a lower grade IMU, it may be a little higher. So if we look at the IMU 31 data sheet,
Ahí básicamente está diciendo que para PPP está bien, o sea, pero que PPRTX debería ser mucho mejor, pero pues que también va a depender del IMU de ellos, o sea, de lo que ellos tengan. Pero entonces, pues básicamente sí. O sea, que para haberlo procesado con PPP, o sea, está dentro del rango aceptable, que es lo que pues, marca ahí.
Yeah, so we were around 8 centimeter, and this is with PPRTX. But with PPP, of course, it'll be less accurate than PPRTX. So actually, with just PPP, more or less, we're actually doing a little better than we would expect because these are the verticals or the down values. So this would normally be less than 0.1. That's a little ugly for me. Let me write this instead with text. So less than 0.1 vertical or down. So that's within spec because of how the data sheet is sharing the expected vertical accuracy.
Okay. Mhm.
All right. And beyond this, where's our forward reverse processing? Let me see. So with the IMU31, there isn't a reverse processing mode. It's just forward and smooth. So we don't have that graph. But these are the places I would recommend checking overall in the error analysis report or the QC report as generated through here.
Okay.
All right.
Mhm.
Now, this is the part we would transition to Riprocess. Just before we left PostPack, is there any particular questions that you might all have?
Si tienen alguna pregunta sobre postpack. No, we don't have. So we could pass to reprocess.
¿A qué archivos se utilizan en el proceso de POSPA?
In reprocess, which files we have to use from postpack?
Yes, good question. So this would be in the prop folder. So we would end up using the SBET and then the Inkaru and the SMR MSG. So these three.
In Paru, which is this file in Paru?
So these files, the SMR and Inkaru, these are the trajectory data quality files. So accuracy, PDOP, things like this.
Son los datos de calidad del procesamiento. Entonces, que por eso se tiene en cuenta. Okay.
And then the
SBET.
SBET is the yeah, of course, the trajectory data directly. So
Okay.
you can usually copy these directly into ON Plus. That way you're ready.
And for these missions, it's only those three files, or probably there are more than two or more SBET files and Cargo and SMG.
Well, this would be per mission, so per lift. So since this flight was done only on one lift, then we only have these three files. But if there are multiple lifts, then you might have however many times per lift. So 3 times lift a number for a project. Yeah.
Sí, pues va a depender del número de misiones que se hagan para ese proyecto en específico, la cantidad de archivos SBET y cantidad de archivos Incaru y esa mierda que es.
Cada misión,
Sí.
cada boot es un set de datos.
Okay. That's okay. Thank you, Travis.
Of course. All right, and just so I have a project that's fresh, I'm going to overwrite the older project file so it's brand new. So when we open it, it will look as such.
Okay. Sí, básicamente lo reemplazo. O sea, y va a hacer las cosas de cero.
So firstly, they'll ask you to upgrade a project if it's collected in an older version of RagWire. This is okay. You can always just press yes. And now it's going to ask with regards to your coordinate systems. So we're actually going to take a bit of a change in topic. And before we talk about Riprocess, we must talk about the GeoSys Manager, which is the software we use to manage coordinate systems.
Es el software que utilizan para la creación de sistemas de coordenadas espaciales.
Okay.
Ahí están asignándole el sistema de coordenadas.
So you can either open it directly here in GeoSys Manager.
En ese, ahí hacen el sistema de referencia.
or you can open it directly.
Tengo que pausar.
Ah,
Like,
Yo creo que mejor que pause mientras.
sí, digamos que se
Sí.
puede esperar unos 15 minutos.
Yeah. Could we do a little break to while we solve some things here in the office? About
sure.
15 minutes.
That's okay.
Okay, thank
Perfect.
you, Travis.
Absolutely, no problem. Alrighty, talk to you soon.
Oh. Hi.
Instead of being there, I put you here.
Thank you, Travis.
No problem. Talk to you soon.
Hi, Travis. Sorry for the delay, but we're having some troubles here in the office, so please give us some minutes. Sorry.
Sure. No worries at all. All good. I'm just